Hello, everyone, and welcome to episode 9 of our series called Software Package Deconstruction: How to Assess Risks to Your Software Supply Chain. Each episode, we deconstruct a software package and do a deep dive into its risk profile to better understand its unique attack vector. And we hope that in some small way, we can enable your security team to stay one step ahead of malicious actors. The subject of today's software package deconstruction is reducing false positives in the SOC with software analysis. Security teams struggle with alert fatigue caused by a variety of factors, which impacts the overall security posture of an enterprise. Too much time is wasted chasing false positives and investigating anomalies that turn out to be normal application behaviors. The information provided by SSCS during the normal app review process can aid security teams long-term by helping tune alerts before software is deployed or address specific concerns or risks with extra layers of detections as needed. And this addition to the app review process can lead to significant resource savings and increased network security. Next slide. The tool that we'll be using to analyze and reduce false positives is the Software Supply Chain Security Platform from ReversingLabs. The SSCS platform decomposes the final deployment software image, describes its underlying software behaviors to determine deployment risks, and when it finds a red flag, it prioritizes remediation guidance. SSCS is powered by the world's largest private file reputation repository, with over 10 billion files and about 4.5 million new files added daily. It not only helps prevent threats from reaching production, but can also find exposed secrets before release. As a bonus, it can also generate a complete SBOM. And with that, let's turn it over to Tim to begin his deconstruction.
Hi, welcome everyone. Thanks for joining us. We have a really good topic today. We're going to address a lot of things that come up when we're talking to folks about TPRM especially, but software supply chain analysis. We know that SBOMs are becoming a requirement. That these are things that you're going to have to do at the very least to check a box. But we want to go past that. We don't want to create the same problems that we've been dealing with in security over the last 20 years or so. Is you get a new tool, you need to create a silo of data that's really valuable, but it sits there. Only so many people know it's there. Only so many people have access to it. So it becomes this really valuable resource, but it's isolated. We want to try and prevent that. We want to try and close the loop here. So if you're going to do this kind of analysis, there's a lot of ways you can make it actionable. Right? And here on our platform, the main areas for that are going to be behaviors and network activity. So the problem with the SOC, and I'm familiar with this because I've managed an EDR at a large, complex organization with spread across the globe, and you have different requirements for different places. Some people are more sensitive to data. Some places don't want this to happen. It depends on a lot of things. When you're doing this risk assessment, you're assessing the software itself, but you have to have that context. So when you do that risk assessment, some of the things you may be looking at are who's going to use this tool? What kind of data is this tool going to access? What kind of data is it going to generate? Where does that data sit? All these things go into that risk assessment. Something that's, maybe Word does some things and it's not that big of a deal. But if there's an application specific to maybe your accounting department or your data scientists, your risk level is going to be a little bit higher for that. Maybe there's some things you don't want to happen there. The problem we have today is the SOC has to manage all these things. There are hundreds of applications on your network, and no one person understands all those things. People working in the SOC have no idea what kind of tools the accounting department needs or these other departments need. They don't know what that tool should be doing, and there's no way to tell what is normal or not, especially for a brand new application. When you're rolling something out to the network, there's no context. If it's something that's been on the network for years and there's a new update, at least you have that historical information to say, okay, we've never seen this in the past. Let's dig into this. What we're going to try and do is avoid that curve, that learning curve. When every time a new application comes on, is to try and figure out who's using it, where does it sit, what is it trying to do, and is it supposed to do these things? When you do this assessment, and when you're looking through these applications before when you're back and you're doing purchasing decisions, and you're comparing applications, and you're doing your initial assessment of which one is best for us, you're going to see all these things. You're going to see the behaviors. You're going to see what it does on the network. If you work together with the SOC, You can close that loop. You can teach them ahead of time. These are the things it's going to do. This is what normal looks like for this application. Here's the information you need. And then that team can take action ahead of time before you do a global deployment. That avoids a lot of chasing these false leads. All of a sudden, all these new domains start showing up on your network feeds or in your SIM. Are they good or are they bad? If you can do that research ahead of time, then you can tune those detections. So this is all about making this stuff actionable, right? So the subtitle of this could be, I have an SBOM, now what? And this is the now what piece. So when you're looking through these networks, and these are just, outputs of actual analysis we've done, and I didn't have to hunt around too far. I looked at 3 samples and got all these examples for this whole thing off of 3 samples. These are just normal things. Software is complicated. It does a lot of different stuff. Part of that, that initial analysis is, do I want it to do these things? If you have something that you notice in the networking section, we're seeing a lot of these new domains show up. These are things that 3 or 4 years ago, like .trade, .link, I would have just blocked these totally. And you tell me if you need something. You prove to me you need access and I'll give it to you. Now you can't really do that because we're starting to see legitimate stuff show up. .xyz for, a decade was a sewer. There is nothing but junk on there now that people are actually using it for legitimate purposes. You can't just assume bad and block, because then now you have an impact. Your end users may be impacted. Then, nowadays you have EDR elements, right, which is next gen AV. Those are behavior based now. So if it takes an action, that can be stopped. Is it running a script? Does it go to a different domain? Is it trying to download something? These can have end user impacts. Depending on who's using the software, those impacts can be legitimate, especially for folks like developers. They have a wide variety of tools and they'll do weird things that seem anomalous, but it's legit for them. But you can't keep impacting them, canceling these threads or quarantining machines. So this is how you avoid that impact at the end. These are also things, this is where you have to drive collaboration. And that's going to be important here. If you're a risk team doing these assessments, you don't have the tools and the workflows in place to check these domains, to understand what's good and what's bad, but you have security teams that do. Give this information to them and let them take a look, and they can tell you what's risky or what's not. And then they can use that information to then put these things in allow lists so they don't get blocked, so you can get updates, so that these different components of your software can work. There's nothing worse than having these intermittent blockages where one person has something enabled or, has a new plugin and it's just impacting them. To understand whether that's legitimate for the software, is that an issue for just that person? This is how you find that stuff out. So you put these things in your allow lists. You can look through, our tool or there are other tools, and they'll tell you what it's going to go to. These are all the URLs that are in this application. For example, this is Firefox install. It needs to be able to check what the latest versions are. But maybe, download by default kicks off an alert in a URL. This, you could give your security team and say, hey, this application is going to check these things regularly. I can put that in the allow list on my network appliances, and I don't see it anymore. This last here, that last URL in that example, on networks I worked in, that would have set off 3 or 4 different rules just based on the complexity of the URL, how it's structured. But knowing that it's good, you can give that to your security team and they don't have to fight through that. Especially, again, when you push this out in your network, if it's a new application, this is going to fire on a bunch of machines and they're going to have to chase this down and figure it out. Do it beforehand and you save all those time, all those resources. Same thing with downloads. You can go grab these downloads if you're not sure, and your SOC can grab that and run it through their sandbox or whatever to verify that these things are legit, which then impacts your risk assessment. Now you have a full scope risk assessment based on these details that a year or 2 ago you didn't have access to. This isn't part of the workflow because it didn't exist before. Now it does. And this is really all about the mandate these days, especially to do more with less. This is how you do that. More with less really just means get max value out of the tools and the data that you have available to you. And this is how you do that. This is how you close that loop. But you don't have to do it alone. Reach out with your security teams, get that relationship going, and you can pull information out of here. And that'll improve your risk assessment and improves your response. The reverse of the allow list is the block lists. Maybe there are things here in your risk assessment that you say, I don't like this. This is a risky thing to happen for us. You can work with the vendor to find out if it's legitimate or not. If it's a necessary piece of the tool, then you work with the SOC to allow that piece. But maybe you still monitor it because I want to know when it happens. I want to know how often it happens. I want to know what gets downloaded. So in here, Bitbucket is sort of like GitHub. It's a third-party code repository. And you see this a lot for code post install. If I enable a plugin, I pay for an extra, element of my software. There may be some follow-on downloads. With these kind of tools, especially with SSES, you can see exactly what's going to get downloaded. You can go assess that. And if I don't want that to happen, even if it's an integrated part of my software, I can block it and make sure it never happens. You'll still want to monitor and know when that happens, but you can get ahead of the curve. And again, it supports you. You're already doing this work anyway, but it makes a huge impact for your security teams because they spend so much time on this stuff and chasing false positives when they should be looking at the things that matter. And this last example here, the deprecated, that is concerning. And that's something you talk to the vendor about because deprecated implies there's a better version of this thing. If you get packages are just abandoned, you don't see that. But in the actual URL, it tells you this is deprecated. It means the vendor should shift to a newer version or a different implementation of this. When you see this, that tells you something about your vendor. Are they checking these things? Are they tracking these things? So there may be other problems. This should be part of your risk assessment. Maybe you can block this for this package, but that tells you that that vendor isn't taking care, isn't doing these checks themselves, and they're handing off these things to you. Behaviors is the other side of that coin. Here we see some outputs from a report that I've actually done through. If you look at the behaviors, this is what it looks like in our application. So that first part up there, you look through the behaviors, and what you want to see is execution. Is what is this going to execute? Because your EDR, that's what it's going to block mostly. If there's script executions, if it's doing any other things with OS files, because it has to do stuff and it wants to grab a Windows DLL, those all trigger in your endpoint application, your security application. And these are all things, this is that alert fatigue. It generates so much noise and the SOC doesn't know where to start. If it's not critical, if it doesn't trigger a block, they still have to figure out whether it's good or bad. This is how you get ahead of that. And the context matters as well. So we can see here, we have an entry at the top or Postgres. That's part of an install package. So that's part of this application that manages the data for this application on the back end. Knowing that is valuable. Now we look at, there's some issues there. So that first arrow goes back, you click on that or the file name, and then the bottom half shows you exactly what the tool gives you. We show you all of the issues with that. So now I have an issue, and from the file path, I know, okay, it is Postgres. That's the file name, but the path also shows me it's more likely to be that. On the bottom, when you click on that link and you see all these details about that file, you can see all the findings. Reading through those, they're medium severities except for one. And that one, the middle issue is just a partial mitigation. It means there's a mitigation in place. The developer put a mitigation in there, but didn't implement it in a way where it's 100% effective. So you have a less effective mitigation. It's high. It's a high priority for a developer, but for a consumer, it's less of an issue. It's good to be aware of, but that's not going to be a deal breaker for me. I'm not going to say, no, I'm not buying this or using the software because of this. So again, it's part of your risk assessment, but it's this extra context that we provide. The verified stamp, that purple icon, shows that ReversingLabs has crawled these things. We go to the source, we pull these down, and we're telling you that we went to the source and we pulled this version down, and the version in the software is the same that we got. So now you can validate, okay, there was no tampering. This is directly from the source. So that helps your risk assessment. You get some metadata down there with the publisher information, whether or not this thing is signed. That all tells you, okay, this is legit, and it should reduce your risk level here. These are all things that help you and then help the SOC. You can tell the SOC, hey, this application uses this. You're going to see database access. Don't worry about that. They can go in and tune the EDR and the rules to make sure that doesn't fire for that application. And this is how you go from, oh, this is sort of risky to I'm taking action and actively reducing the risk. right? Now I can put in these compensating controls to stop the things that I don't like. There's some more examples here, and these are all things that'll fire on your EDR, and they may cause things to be blocked. They may terminate that thread, or they may quarantine the machine, depending on how you're set up and what tools you're using. But these are all, again, legitimate elements that come from one package. These are all things that happens. WMI is a Windows interface that pulls information from your machine, but it registers as a script execution. So again, this may show up and just, you deploy this on 100 machines and you're going to see thousands of alerts. And the SOC's going to have to wade through that and figure it out. Get this in beforehand, then it can do that. And I will just alter the rules to allow this application to do these things without being blocked. And these are all normal things, right? A WMI, your application may need to know what's on the system, so it adjusts how it is installed, how it's configured, that kind of thing. So some of this is normal, but you have to know that going in. As we can see here, the remote desktop example on the right, they're all yellow because you can go into the system, and this is one of the searches I do with a new piece of software, is I want to know, is it doing any remote connections? Is it touching the microphone? Is it touching the camera? Is it taking screenshots? If it can do all of these things, that should be feeding into your risk assessment. Same thing with security products. At the bottom here, we see that this application made changes to Kaspersky. Now, that just may mean the vendor knows that there are some impacts with that, and they need to make a change, or they may do an exemption in Kaspersky to prevent things being impacted. We see that a lot. It's not necessarily bad, but you have to be aware of it. In this case, if you're not using that, then it's not a problem. But if that's your AV, then you're going to have to put in some adjustments to your detections to ensure that these aren't getting prevented. And you're not, sending a million alerts to your SOC that these junior analysts are going to have to just keep pulling the thread on. Here are some more examples of behaviors. Again, this is like we talked about. Depending on what your software is going to do, it's going to leverage OS elements. We see a lot on medical devices. That's a thing that pops up because the software is an interface to an actual physical device. Could be an MRI machine, could be a blood pressure machine, whatever. But it has to enumerate, all the attached devices. It has to do all these different things using low-level OS elements. If you know going in that this is going to happen and you hit your SOC, they can adapt the detections ahead of time. This is a huge cost saving because this is 80% of your day as a SOC analyst. This is new. We've never seen it before. Okay, is it good or bad? And then over and over and over. The more time you spend on the things that don't matter, the more chance that something does matter slip through the cracks. So these are all good ways that you can actually have an actionable impact, and you can effectively reduce the risk score of these things by doing this ahead of time, implementing blocks. Now the risk score isn't your best guess based on limited information. Now your risk score is something that you can impact, that you can have an adjust on. These are enterprise level impacts that you can have on work that you're already going to do anyway when you do these risk assessments. So it's about getting the maximum value out of workflows and information that you have on hand. So that was all. I mean, this is a pretty rich topic. I think this is part of the, software supply chain assessments and risk assessments. It doesn't get sort of touched on a lot. Is how do I do this thing? Great, I come up with a score, but what's next? And this is that what's next piece. So hopefully that all made sense. That's all I had. So is there any questions out there?
Does not appear to be any questions. Okay,
Outstanding.
let's go ahead and move on. Next slide, please. Okay, well, thank you, Tim. And by the way, for those of you interested in analyzing your own software supply chain security profile, we've got a 14-day free trial available to you of the same software that Tim just used to reduce false positives in the SOC. It's available at the link that should now be in everyone's chat. By the way, there's no credit card required or software to install. Just create an account and you'll get 14 days of free access to a full-blown version of our software supply chain security platform. You can use it to analyze malware and code tampering embedded in your software components, or generate an SBOM listing all open source and third-party packages and software you're using, or leverage the platform to contextualize and prioritize alerts and threats in your software supply chain. Again, there's no charge, so please take advantage of this risk-free trial. Next slide, please. In case you missed yesterday's Reversing Labs quarterly product update webinar, where we reviewed our latest updates and releases while providing a preview of some great new features coming down the pipe for our customers, you can catch it on demand under the Resources tab on ReversingLabs.com. And be sure to also check out 2 of our upcoming webinars, one on September 27th, where we dive into static versus static binary analysis, and another on October 18th, threat modeling and software supply chain security, why it matters more than ever for risk management. And the next episode in our software package deconstruction series will be Thursday, October 5th, and we hope you can join us for that one as well. Next slide. And that concludes this episode of Software Package Deconstruction. Thank you all again for attending, and please be on the lookout for announcements about future episodes from Reversing Labs. Have a great rest of the day, everyone, as well as a great rest of the week. And remember to broaden your view of software risk by securing your entire software supply chain.